Okay, thanks for coming and not running off to get in line for your new toy. My name's Eric Sachs. I'm a product manager at Google. Currently, I'm a product manager for two different teams, the Google security team, as well as I'm actually the product manager counterpart for Google's CIO, which is an interesting pair of responsibilities, but we're actually doing a lot of work in the security area to offer our CIO, sort of our internal enterprise team, some new options to use cloud computing. I'm going to spend some time talking about that today. I've actually been at Google now almost 6 years, and prior to that, about 10 years in the corporate email hosting environment. So I've been on both the enterprise and consumer side for a long time. And what I'm going to focus on today is sort of the mishmash of different standards in the security space, especially ones that are used in more of a cloud computing web services environment. And in particular, I'm not trying to make all of you security experts. What I see as my goal as a product manager is to make people aware of new solutions to problems in the past that just seemed unsolvable. And so, I get this from a lot of people who talk about themselves as being security experts, that, hey, I'm a security expert in area 1 and 2, but trying to keep up all of the rest, I just can't. And in particular, I wouldn't even suggest trying. Learn the areas that you care about, and then keep an eye on those. No one can keep track of all of this stuff. And in particular, one of the themes we're going to talk about today is that a lot of technology has been developed in the consumer space the last few years for security purposes, and is actually being really heavily adopted on the enterprise side. And in fact, the consumer companies who created some of this stuff, they weren't pushing for the use of it in enterprises. Enterprise grabbed it and have run with it, and to be honest, we're catching up as much as anything else. So I'm going to go through two primary sections today in my presentation, and then at the end, apparently now we should have a good 20 minutes for Q&A, so we've got mics set up at the end for people who want to ask questions, and we are videoing this, so we're going to try to ask people to come up to the mic when they do have questions. Two sections that I'm going to go in today. The first, federated login, something probably a lot of you are familiar with. However, historically, this has been more of a large enterprise type of thing. What I want to talk to the audience today about is, what if you're a small or medium-sized business, or what if you're a software as a service vendor? There's a lot of interesting evolution in this space that it's worth knowing about. And then about 2/3 of the session today, I'm going to be talking about web service authentication. I don't mean a web service authenticating an end user logging in. What I mean is web service A making a call to web service B, say to make a request to change someone's salary. And we're going to talk about how the receiving web application identifies the calling web application, and a whole bunch of scenarios where this gets interesting. So let me jump into this first part, sort of this federated login. So many of you have probably, experienced this yourself, working either at a large enterprise where they've deployed a single sign-on system across a bunch of corporate applications, or maybe you experienced this as a corporate user of, say, a Google, Yahoo, where you logged in once, and all of a sudden you logged into a bunch of services from those providers without being logged in. So traditionally, this has been more of a game for large enterprises, large consumer websites. And most of them purchased packaged software products, for this. And the standards in this space, pretty well evolved, really solid. However, if you're going to run this, you have to be prepared to make sure that this system is up and running all the time. So, we're talking about servers in multiple data centers, multiple, servers even in the same data centers to keep it up and running. And things start to get a little bit more complicated, especially in the large enterprise scenario, if you then want to enable some of your employees to log into some software as a service application, Salesforce, Google Apps being examples. And you want your employees to log into them without having to enter their password again. So that's sort of the traditional example. But let's talk about some of the stuff that's happened in the last year or so, which is that a lot of small and medium businesses said, this sounds great. I'm going to go buy one of these single sign-on software packages. I'm going to deploy it on my Windows Active Directory server sitting on the desk over there. And they've got a sort of a term for this. SSO is sort of the abbreviation of single sign-on. Well, within small and medium businesses, they like to make the joke of now it's a single source of failure. And what they mean by that is a lot of companies had the experience of they deployed one of these systems, sitting under someone's desk, 10 o'clock at night, that server dies, and their CEO is in India and is trying to log into one of the applications like their email system. And even though the email system is up and running, their login system is down. So if you're a small, medium business running this on a single server in a single office behind a single internet connection, don't do it. It's not worth the pain you're going to cause. So seeing this, a number of vendors in this space, Ping, Simplified, some others, realized, well, wait, there's an opportunity. Instead of providing this as software to these smaller companies, let's provide a service to them. Just as companies can outsource their email or their calendars or their 401k, now they can outsource running one of these identity provider services. Like I say, you can do this today with a couple companies like Ping and Simplified, and then a lot of the email hosting providers, Microsoft, Lotus, Google, Yahoo, et cetera, are working on clarifying the standards so that we can offer this same functionality as well. And so, the goal is that, that CEO traveling in India, if he wants to log into any application, it's a highly reliable web service that is taking his password, figuring out who he is, and then handling the job of getting him logged into the different applications he wants to hit. So let me give an example of how this might work. So this is an example of a company called Aperio, who's really heavily focused on using cloud computing, software as a service offerings. They try to have really minimal desktop laptops for their employees and use services like Google Apps for Mail and Calendar or Salesforce for their CRM application. And what they would have liked to have done in the past is they would like for their employees to log in on one web page and then be able to go to Salesforce or Google or Plaxo or some other enterprise app and just be signed in again, magically speaking. However, they haven't been able to do this historically. Well, one of the things that we've been working on with Ping Connect and the OpenID standards community is a way of actually making this work. So Ping is a company who has sort of the red box on the right. They're really experts at a lot of this federated login technology, and they've realized how to make stuff talk to us in Salesforce using a whole bunch of protocols, other SaaS vendors, business-to-business partners, even sort of down in the bottom left-hand corner, hooking back into applications you might run on-premise. They're good at that, but still somebody has to be responsible for asking the user for their password. So in this case, what we did is we said, you know what? Tom at Aperio, he's already used to going and logging into his mail service operated by Google. So Google knows how to authenticate him. So we used OpenID, which is another federated login technology, as sort of a glue between Google and Ping. And we said, hey, let's have Tom go and log into his mail. He's all set. Now, if Tom goes and types salesforce.aperio.com in his browser, he's going to get redirected to Salesforce with the request to access Aperio's information. Salesforce will say, oh, OK, well, that domain's logins are handled by Ping Connect. They'll route him there. Ping Connect will say, oh, OK, well, now I need to check who from Aperio is logged in, bounces the user back to Google, and Google says, OK, well, it's Tom. Tells Ping Connect it's Tom, and Ping Connect knows how to talk the variant of federated login that Salesforce uses and tells them that Tom's logged in. And the same thing applies to a bunch of others. Ping can make this work, like I say, to these business partners, to these enterprise apps, et cetera. And so we actually have this live and running with them now, and hopefully once we finalize some of the OpenID community standards, make this more generally available. One of the other things to note is there's another purple box in the middle labeled Plaxo, which points out that as these standards do coalesce and really become not standards with some variance, but standards with very little variance, it's even possible that some of these email hosting providers, whether it's a Google, a Yahoo, a Microsoft, any of us can act as a federated login provider directly to an application. And so Plaxo is one who, for example, already does this with Google today for our Gmail users. So, Tom, all of this stuff is invisible to him. He enters his password once, goes to any web app he needs from the enterprise, he's logged in. For a small and medium business, they're already used to using their email outsourcer. Ping just becomes, one more box in the picture that handles a lot of the complexity for them, and usually it's just a bunch of checkboxes to get set up. So we have a couple different audiences here. So some very specific feedback for first, those of you who deal with small and medium businesses. Then we're going to talk about those of you running software as a service opportunities, and then those of you who are geeks like me. So first, small and medium businesses. Like I said before, don't try to run your own login system, under someone's desk that's going to die when your executive's traveling. You're just asking to get yelled at. Either just don't. Either just require your employees to log into all these applications independently, which is annoying but not the end of the world. Or look at one of these service-based offerings that can provide this in a more highly reliable way. And another thing to keep an eye on is, this type of glue that's happening, as I was just showing in the previous diagram, this is evolving quickly. These service providers are offering a lot of other options, integration with these different protocols, integration with some stronger authentication mechanisms, if that's really important to you, though has its own usability challenges. And let's say a lot of enterprises are really pushing vendors like Ping, like Google, to make better standards for how to provision new users across a bunch of apps or use group membership across all of them. These are things where the standards are evolving. If you got a lot of time and want to monitor them, great. If not, let one of these experts deal with it for you. So that's some guidance if you're a small, medium business. Well, some of you in the room run software as a service offerings, whether it's for targeted at small businesses, medium businesses, large businesses, doesn't really matter. You're almost certainly going to get pressure from your enterprise customers to support this type of federated login. Their security guys, hate it when they have to take their employee passwords and send it to a bunch of different vendors. Historically, most of this pressure came from larger enterprises who could run these systems, but what we've seen over the last year is that as a lot of medium-sized and even smaller businesses are deploying these service-based identity providers, they're now putting pressure on their SaaS vendors saying, hey, I finally got one of these things. I want to use it. I don't want my employees to have to log in yet again. So if you, as a SaaS vendor, start feeling this pressure, you have three choices. One is, well, these are standards. You can read them. You can roll your own. And I can pretty much guarantee you're going to make a security mistake, because even experts like Google and Microsoft and Yahoo and Ping do. This is hardcore stuff to get all the crypto right. So more traditional option is just to purchase one of these software packages from a vendor in this space. There are plenty, CA, IBM, Oracle, Ping as well. And then one of the more recent trends is we're just talking about the fact that a small business can subscribe to a service that runs an identity provider. Well, the reverse is true. Some companies like Jan Rain, who offers a service they call RPX, as well as Ping, are going to SaaS vendors and saying, hey, you don't want to run all this complicated software on your site? Fine. We'll run it for you as a service on the internet, and we'll just need a small sort of last mile connection from the relying party they run on behalf of your company to your company's website. So the last audience, and I'm hoping there's some of you in this room, or actually, okay. One more annoying thing for those of you who are software as a service vendors. If you want to run off and do this today, two warnings that we've learned from talking with other SaaS vendors who've done this. The first is take a look at whether you offer any desktop software that integrates with your applications. If you do, you're probably going to be really annoyed when you realize that you've hard-coded it to ask users for their email address and password. Google's done this. Salesforce has done this. Facebook, fortunately, avoided it. But most of us made this mistake that our desktop apps are just hard-coded to ask for email address and password. And if you do this federated login thing, all of a sudden, you don't have passwords for some of your users. So you're in trouble. Not going to spend a lot of time on this. If you want to see about best practices for solving that, there's a technology called OAuth that does it. Down at the bottom, there's sort of a web link you can search for, Google OAuth, and there's some more detail there. Just look for information about desktop apps. The other challenge for software as a service providers is, well, they have to decide what their login box looks like. Most of them, if they have a login box, it's the traditional one. Ask for email address and ask for password. And if all of a sudden some of your users don't have a password, you have to decide what should it look like instead. Different options depending on what type of vendor you are. One of the more common ones is just to take away that password field, ask the user for their email address, and then look it up and decide, oh, is this someone where I have a password for them, or is this someone where I'm using one of these federated login technologies? But the last thing I wanted to mention, like I say, if you had a question, did you want to come up, or I can repeat it?
Yeah. Will the slides be made available?
The slides actually, if you do this search for Google OAuth right now and go to the first website linked and search for Google I/O, the slides are already there, and a video of this is supposed to be up, I think, June 1st, if I remember correctly. All right, so like I said, this is a pretty technical audience. There's some unsolved challenges left here. A lot of great work is being done, not just by big companies, Microsoft, Yahoo, Google, AOL, et cetera, but some really innovative stuff coming from smaller companies, in particular ones who are just willing to just throw out past assumptions and try something new. So if you want to get involved in this space, there are a couple standards listed up here, OpenID, OAuth, SAML. They all have public mailing lists. You can monitor them, see what's going on in this space. And there's some challenges that we're dealing with. By far, the number one is about usability. I have to admit, this is an area that's very interesting for us in the security community. We normally hide in the corners and try to kill the bad demons. Now we're actually spending a very large portion of our time learning from usability experts about how to make this security technology helpful as opposed to annoying. We're very good at making it annoying. That we know how to do. And like I say, a couple other things, easier setup for administrators, improving the security whenever possible, and then the provisioning and group membership stuff that I talked about. So, that's the first section. Like I say, good vendors in this space, take a look at them. If you're a SaaS vendor, realize you're probably going to get some pressure to become a relying party over the next year. Hopefully this has some good pointers. Let me dive into now the next section topic, a little bit more complicated, and we're going to spend about 2/3 of the time here. So I mentioned that I have two jobs, a security job and product manager with our CIO. So I spend a lot of time with industry CIOs, government CIOs. And one of the things that's been really fascinating spending time with them is these guys are really looking at cloud computing technology as a way to reducing their operating costs. They want to use things like Azure, Amazon, Salesforce, Google App Engine, et cetera. And they're interested in it not just for services like email and CRM, but for these quote-unquote platform-as-a-service offerings where they can run entire apps on Amazon Web Services or on Google App Engine. However, as soon as they start playing with this, the common refrain I hear from these CIOs is, okay, if I have app A running on one cloud computing vendor and app B running behind my firewall or in another cloud computing vendor, how are those two going to authenticate to each other? So, forget about end users. And so here's some very specific use cases that I'm going to walk through today that are probably the most common, well, they are the most common ones that I've been asked. So the first is, a more simple one. Great. I'm just trying to deal with cross-platform connectivity. I've built my front end as a Windows server. I got a back end running as Linux, and I want that, Windows server to make, application calls, RPCs to the back end. Well, how does the back end know the requests are actually coming from that Windows server and not some other rogue server in their environment? Multiple ways to deal with this. We're going to talk about one that can also help with scenarios 2 and 3, which is the next common scenario I see is a lot of companies have said, oh, well, there's stuff I can do at Amazon Web Services where their offering really meets my needs, and then there's other functionality I can more easily do on App Engine. But how do I combine the two? How do I have my administrative console on App Engine making function requests to my application running on Amazon to tell it to, say, restart or create more instances of itself? These are powerful operations. You want to make sure that the app running on Amazon wants to make sure it's getting these requests from the proper source. And then the most complicated one, and especially for enterprises, is that it's almost guaranteed that some of their data is going to be behind a firewall. They're going to have some software running on-premise. So how do you integrate or mash up an application running in the cloud and an application running on-premise behind the firewall? So we're going to talk about each of these three use cases in turn. And in particular, we're going to talk about one technology standard called OAuth that can help in a lot of these areas. Now, I'm not going to tell you OAuth is exactly what you should use in all of these cases. In particular, the first example of Windows Server talking to Linux server, bunch of different options to do that. However, If those two applications are separated and can only communicate through a firewall with an HTTP proxy, which is, a common thing. Like Google App Engine apps can only make outbound calls, via HTTP, and a lot of enterprises only allow inbound requests through HTTP. Well, if you've got that limitation, a lot of web developers, even before they get to the secure part, make a decision to use REST-style APIs. And if you're not familiar with that, I'm going to give an example. But these are APIs that are designed to look like requests to load a web page. So they flow through standard HTTP proxies, firewalls, et cetera. All the advantages of OAuth, though, the biggest one it has is right now it's really simple. It's only a couple pages spec, and in fact, in the enterprise use cases, you can usually ignore all but the first page of the spec. So that simplicity really attracts an audience because in general in the security space, the more complex something is, the more likely you are to get it wrong. And then did I see at least Brian Eaton here? So one of the other things I'm going to note is, while I have some time at the end to answer some questions, we're actually running a help desk that is on this floor. Okay, there's a help desk right on this floor. And Brian can stand up now, and everyone can look at him. Brian is one of our OAuth experts at Google, and we have another one there as well, who you can dive down deeper in some of this stuff if you're interested afterwards. Okay, so I'm going to talk about some very specific examples. The top thing right there is ignoring all the security stuff. What does a REST API call look like? I'm guessing 90% of you all do, but just in case, it's an RPC, a remote procedure call, that looks like the type of thing you would type into your web browser's URL. So the top request is actually a request to change Sarah's salary to $90,000. And in this case, it's running at the salary endpoint on acme.com. And if they chose to, they could put this up as a web server that anyone could type that URL in their browser and change Sarah's salary. Now, they probably want to add some security to that, I hope. So let's talk about some ways they can do that. In particular, the example I want to focus on, though, is if they've exposed this type of REST API interface, and they expect a front-end application to make calls to it. So it's not a two-tier user hitting the endpoint directly. It's user hitting some front-end app, and the front-end app then wants to change Sarah's salary. How is the front-end app going to make that request and verify where it came from? So what OAuth does, the very simple version, is it says, you know what? Take that URL that was created for the API call and just add two things to it. One is a user URL parameter with just the claimed name of the calling application, and you get to decide what this is. Best practice is to use something that looks like a domain name, but to be honest, it can be anything, any string that's unique. And then the trickier part is this last parameter, this OAuth signature parameter, and what this is designed to do is to prove that the request actually came from a specific source. And so this is where the hard part happens. And so I'm going to have to give you guys a little bit of the hard part here, the crypto part, and then I'm going to talk about, hopefully over time, how you can stop thinking about those things. Because like I say, the end goal is to make security simple where possible. However, if this is something that you're really interested in, you want to jump off and start using this OAuth type stuff, it is an open standard. There are good open source libraries for it that you can take a look at on OAuth.net. So Crypto 101, or called maybe Crypto 50, it's a really short version. If you start playing with this stuff, you'll find that the calling application and the receiving application are going to have to agree on some secure way to communicate with each other. The first choice they usually have to make is between two of the more common crypto algorithms. You'll hear the words HMAC and symmetric is sort of the simpler one. Appears to be more common in the enterprise scenarios. RSA, a little bit more complicated to set up. If you really want to understand it, grab some books. It's not immediately obvious. Does have some security advantages to it. So the calling app and the receiving app have to pick one of these two, and once they've picked it, they then have to either exchange with each other a shared sort of password, which in this case they call a secret, or in the RSA scenario, there's sort of a pair of secrets, and each guy knows, roughly speaking, one of the two. So let's assume that's done. Let me go back to one of the first examples I gave that I get asked about by CIOs, how do I have a front-end Windows server talking to a back-end Linux app, cross-platform from each other. The first two part, pretty standard, create an API endpoint on the Linux server, call it from the Windows server. Nothing particularly tricky there. The third part, not too hard. The Windows server adds one more URL parameter with the name of the calling application. And by the way, I see a lot of people standing in the back. There are a bunch of seats up front if you all want to come up. A couple of you. It's where 4 and 5 start to get a little bit trickier. Step 4 is where, okay, these two people, the administrators of Linux and Windows Server, do have to talk with each other, agree on a crypto mechanism to use, exchange one of these secrets with each other. And once they've done that, they can hopefully grab one of these open source libraries for Windows to sign the request and for Linux to verify the request. Step 7, by the way, is an important one that's sadly left out a lot of times, which is, let's say that Linux server is willing to accept requests from a couple of different Windows front ends, but with different privileges. One of the Windows front ends is allowed to, say, change salaries, and the other one is only allowed to read information out of the system. So it's not enough for the Linux server to just verify the request is properly signed. It then has to look at, oh, okay, and who did it come from and what operation are they allowed to perform? We sadly see a lot of cases where that step gets skipped, and people assume just verifying the signature is enough. So some of you have laptops or phones, hopefully have started Googling OAuth to learn a little bit more about it. One warning, if you do, I mentioned before, this is a technology that started in the consumer space and now has evolved into the enterprise space. If you start reading about it, you'll see a lot of references to consumer brands, Yahoo, AOL, Google, Flickr, a bunch of others who created this. One nice thing to know is they created it not from scratch. They all had sort of proprietary variants of it ahead of time. They tried to merge their best practices, come up with a common standard, and the security guys of all these companies keep on banging on it and looking for ways to improve it. So you get to leverage all of that experience. However, if you read about the OAuth standard, you'll see a lot of description of flows where an end user has to approve application A and application B talking to each other about that user. Consumer scenarios, that makes sense. You want user consent. In enterprise scenarios or web app to web app by itself, usually don't need this. It's overly complicated. So if you read about OAuth and see anything about tokens, just skip to the next section. If you see the word token, you just skip to the next section. If you do that, you end up throwing out about 2/3 of the OAuth spec, and you're left with something that's pretty simple. Pretty simple, but we always want to try to make it simpler. Like I say, get to the point where security is just this invisible glue down at the bottom. And so let me talk about another standard. We talked about OpenID and SAML at the beginning. We just talked about OAuth. I'm going to throw in one more for you, which is OpenSocial. So another consumer-developed standard. However, one of the things that the OpenSocial community realized is, you know what? In the cloud computing environment, a lot of times the applications are run in a container. And the container knows the identity of the application and can provide some services to it to help with things like identity management. Google, App Engine, Salesforce, for example, provide a lot of features in their containers, so do OpenSocial containers. And what they realize is, hey, the container can provide a function call to the app to handle all this OAuth signature stuff on the application's behalf. So if the app wants to make this REST call to change Sarah's salary, it just goes to the container, looks up the container's specific function to proxy one of these URLs, and says, hey, container, I want to call this URL, and please, can you handle all the signature stuff for me? And this is, like I say, already live in OpenSocial containers, and what the community right now is trying to do in the OAuth community is standardize this working for other containers, whether it's other Google containers, Salesforce, Amazon, Yahoo, et cetera. So let's assume that you do take this type of approach, and and your container can sign requests. Well, the recipient is going to get something that looks like the request at the top. And one of the things that hopefully you'll notice from here is there are now 3 special parameters added instead of 2. Before there was this signature and there was this consumer key. Now the OpenSocial guys came with this idea of, well, let's throw in a claim as to the source of the calling application. Microsoft loves to talk about claims-based identity management. In this case, the container, appspot.com, is making the claim that it is signing a request on behalf of a particular app, like hrtool.appspot.com. So you do this, it takes all of the signing work off the application, and there's another advantage to it, which is that the containers can, and certainly do in the OpenSocial world, they can document how they're going to do the signing, how they're going to do the crypto. They'll give very good sample code as to how to verify these requests. So it really offloads a lot of the complexity for the developer, especially the developer creating the front-end application. So let me give an example now of how this could work once we finalize standards for how a container like App Engine can do these requests. Though, to be honest, if you want to play with it, just look at how OpenSocial containers do it. 95% finalize this stuff. So the first thing is, okay, the Amazon app, the one not running in the container, still needs to expose an API endpoint. And the calling app still needs to make a request, with one of these REST API formats that looks like URL. Now, though, the only thing that's left is, nothing more for the calling app to do. The Amazon app just needs to look at the documentation in the container, find out what format it used, how it's handling digital signatures, hopefully even grab some sample code, verify the request came from this app, and, like I was mentioning before, also check that application has the ability to perform this operation. Even more dangerous, number 4, like I said, I'm going to be really anal about calling this out again. If the code for verifying requests from a container is consistent, that means in this case that the Amazon server will be able to verify a signed request from any application running on that container. So if all you do is verify the request came from that container and then allow it to say, change Sarah's salary, you're in trouble. You need to take the extra step of looking at that previous parameter, this app URL, and making sure that it is the trusted source for making the request. So if you want to play with this now, like say, you can do this today. You don't have to wait for us to finalize a mechanism for the container to do the signing. Do a search for OAuth, Google App Engine. There's software examples out there that do this today. Not too hard. Like say, a bunch of enterprises are already using them. Again, assuming you're comfortable with that. If you want, wait a little bit longer or start out with just the gadget functionality, which already does this signing. As soon as the industry standard community signs off on it, this is sort of the nice thing, right? You don't want individual companies deciding the final standards on this, because then you're just going to have to do a one-off on it. So we want to make sure that, and I'm going to get to this end, a bunch of us have agreed, okay, we're all going to do it the same way. Right? He was asking when it was available, and I was saying when the community as a whole is, agree with standards on it. Google's not trying to do this on our own. Okay, let's make it a little bit more complicated. We talked about, Windows Server hitting Linux Server. We talked about App Engine app talking to Amazon. Well, let's say you're trying to break your way through a firewall. You have an application running on, App Engine, or to be honest, on Salesforce, on Azure, et cetera, on Amazon. And you want to connect to, say, some APIs exposed by your ERP system. Well, now it gets a little bit more complicated. There are 3 things you need to do. The first is you're going to have to find some way to tunnel through that enterprise firewall to the ERP system. Different cloud computing vendors offer different ways to do this. Google has an offering called the Secure Data Connector that's designed to help with this. There's sessions about that later today. Other cloud computing vendors, suggest using more standard point-to-point VPN tunnels. The standards there are pretty well established. So that's, the first thing you need to do. Second thing you need to do is, this OAuth-style interaction to verify the source of the request. However, then there's one last thing, which is in most enterprise situations, you don't care just about what front-end app is making the request. You care about what user is logged into that front-end request. So, who is it that wants to change Sarah's salary? Tends to be an important question when dealing with like an ERP application. And this is, again, a case where the OpenSocial community saw the same problem and came up with a way to address it that a lot of enterprises are adopting, which is they said, okay, well, we just need to pass another claim as to the identity of the user. And so the application, can pass along that claim, and it's really up to the backend to decide, does it trust it? Maybe some applications it trusts to, identify our subset of users. Other applications it trusts to identify a whole set. But in any case, the calling application is just going to pass along another URL parameter with the claimed name of the user who's logged in. You could make this URL parameter named anything you want. However, there's a lot of value to being, having standards about this. To answer your earlier question, there's, a little bit of variance can be annoying. In the OpenSocial community, they've chosen the parameter OpenSocial viewer email as a common one in this scenario. And let me give you an example of why it might be helpful to follow that standard. I'm going to reverse this now. The previous example is, okay, an app on App Engine trying to make a call back through the enterprise. What if it's the reverse? What if an enterprise is using some software as a service vendor, Salesforce or Google Apps, for example, and it wants to make a call into that SaaS vendor? So a common example Google gets is we host a lot of companies' email and calendar offerings. And we actually offer a feature right now where what an administrator can do is go to Google and say, you know what? I'd like to turn on this sort of two-legged OAuth interaction for my domain. I want one of these OAuth consumer keys and secrets. And once they have that in their hands, they can actually write an application themselves, run it wherever they want, and it can make these two-legged OAuth calls back to Google. And Google will say, oh, I just got a request to, in this case, return the calendar for Tom in a certain domain. Well, one of the things to note is if the consumer key and consumer secret, if all it does is identify the domain, and the domain wants a particular user's data, it's going to have to tell us what user's data it wants. So we as Google had to decide what URL parameter we require for this information to be passed in. To be honest, we used a couple different ones because the community is still trying to finalize some of the standards on this, though it's really just standards of picking names to make things as simple as possible. So OpenSocial viewer email, like I say, is an example of such a name. This is another topic all of in itself. If you are a company who has outsourced Google, if you are interested in learning more about how to build your own apps to access these APIs, it's another session, building enterprise applications in the cloud, that's worth going to. Common example of using this is maybe you want to upload a bunch of data about your users into the system because you're migrating, or you want to scan the data at your SaaS vendor for legal compliance searches, that type of thing. Again, though, I want to get back to my theme of how simple can we make this? So we talked about before that the OpenSocial community had this idea of, hey, allow the container to sign the request on behalf of the app. Well, in the OpenSocial world, what they actually do is the container, in many cases, knows not only the identity of the application, it also knows the identity of the user who's currently logged into that application. And so what the container will do when you add this signed parameter is it will actually add that viewer's email to the assertion. It does this by default. In fact, I'm not even sure how you'd turn it off. So now the container is passing through the claim that Tom is logged in and the claim that it's this particular application that's making the request. And to sort of steal some of Microsoft's terminology, these claims are all a matter of trust. Does the backend application trust these claims? And one of the things it asks aside is, does it trust the calling application to get the crypto right, to do all the digital signatures right? And in many cases, you're nervous about your average software engineer doing this right. However, if the container is run by an Amazon, a Salesforce, Google, Yahoo, you can be pretty sure that they've gotten this right as we know how, and they'll evolve it over time if need be. So in many cases, these claims are considered even more trustworthy than if the application sent them. And to give an even more specific example is, right now the container is asserting that Tom is logged in. Well, that's an interesting piece of information that not only is the action being performed on behalf of Tom, but he's currently logged into that application. That's not an easy claim for a standalone application to make and for something else to trust. So, the app can claim that Tom's logged in, but for the container to make that claim, in many cases, it's more trustworthy. Again, claims of trust, it's really matter for you to make, your decisions, but this is one of the advantages of containers.
So does the container keep track of the cookies associated with this session?
So we were just asking, more generally, how does the container keep track of, the session cookies or other mechanisms to identify who Tom is? There's a lot of variance containers. The way that gadgets do authentication of users is actually pretty complex because you have multiple individual applications running on the page on the user's browser. So there, you have to deal with complications. It's not just code running server side. So significant complexity there. For things like Salesforce.com, App Engine, et cetera, if you look at them, they already provide to applications a way for the application running on those platforms to tell who is logged in. And so the same way they do that, they're just adding that to these assertion information. So it tends to be proprietary to that platform as opposed to standard. And in this case, that's fine. But our key goal is to have a standard for how we assert that information. Does that help? We could drill down to it more afterwards if you want. Okay, so we spent a lot of time talking about how to make it easier to sign these outbound requests and things the industry is doing to hopefully over time make this even simpler. However, there's still the reverse. The calling application still has to verify these signatures. Fortunately, this is much simpler. I mentioned before that if the signature is coming from a container, a lot of these containers have really good docs on how to do it, really good sample code. However, there still is a chance for mistake. So one of the things that we're trying to figure out is how can we provide sort of the reverse of the signing feature and instead just verify that one of these requests came in. So, for example, a container, an App Engine to Salesforce, Amazon could provide a service to verify these requests. And, if you want to make a call into it, then you would go to Google or Yahoo and say, okay, how do I get one of these consumer keys, consumer secrets, so I can make an inbound sign request? If you want to play with this today, like I said, there's already software available to do this. Search for App Engine, OAuth Verify for a couple examples. But it is software. You have to bring it in. If it gets updated, you have to keep track of that. So that's why we want to make this simpler over time. So we're actually getting near the end. So if you can start thinking about your questions, we're going to kick this up 2 more levels to make a key point at the end. Let's talk about how simple we're trying to make this, which is, let's use the example of 2 GAE applications. What if you decide you want to write the front end of your application on the Python version of Google App Engine, and you want to write the back end in, say, the Java version of Google App Engine? But you need a way for the two to securely communicate with each other, and your back end wants to make sure the requests really are, in fact, coming from that front end app. This is possible today. Plenty of developers have already done it. Many of them use this OAuth software mechanisms to do it. However, our goal is to get to the point where that first application just makes a sign request following this OpenSocial style standard, and the receiving system gets the URL listed under GAE App 2. A request to change Sarah's salary, where it sees it comes from Tom, sees the calling GAE application, and all it does now is verify the signature is accurate first. Second thing, like say, very, very important, don't forget this, make sure that the app who made the request is actually allowed to perform the operation. Verifying the signature by itself is not sufficient. And now I can look at the value of Tom and Sarah and see, hey, is Tom allowed to change Sarah's salary? Is he her boss or an HR manager? So, this is a goal, replace the software for URL verify and the software for URL fetch, with services that can do this interop so that the applications just need to perform these access control checks. That's between 2 GAE apps, though. The reason for trying to do this as a standard is, like say, you can already do that. That's not the most interesting thing in the world. What the OAuth community and what other companies are trying to do is figure out how do you do these mashups across cloud computing platforms? How do you have an app on Azure make a call to an app on Amazon, or an app on Salesforce make a call to a Google App Engine? And for the containers to establish standards for how to do all this crypto to each other so that you don't even think about it. You just say, I want to make a request. Here's the URL of the endpoint I'm trying to hit. I want it signed. If you're the receiving system, you get the request. You say, I want to verify it. Oh, great. It came from another container that interops with the container I'm hosting. This is where the community is trying to get, is use OAuth as a way to do these types of secure mashups across different cloud computing platforms. And so, for those of you who want to do stuff like this today, the software does exist. Plenty of enterprises use it for some pretty high-value transactions. Look at some of the websites or web searches I've referenced to get more detail. But in particular, I'm hoping this very technically sophisticated audience, we, just like in the federated login space, we are looking for more people to help us, flush out these standards. We have great people from all these different companies, Microsoft, Amazon, Salesforce, and Google. represents a good mix of vendors in this space, but we'd like to hear more. In particular, many of us are a little bit more focused on the consumer space. We need a bit more enterprise perspective. To be honest, sometimes we need to be banged up the side of the head to remember that the enterprise segment is a little bit different. And so if you want to get involved in this, OAuth mailing list is a public one. There are other great industry conferences like the Internet Identity Workshop that just happened last week, where there's a lot of good discussions to finalize this stuff in the next few weeks. And so I'd hope you would come to that in the future. So in general, I'm going to stay around for questions for people willing to go up to the mics. I'll also be around afterwards if people want to catch me in the hall. If you want to learn even more about OAuth while you're here at the conference, stop by the OAuth help desk. And if you want to get more details about pretty much anything I talked about, I'd say do a Google search for OAuth Goog. The first website there has a ton of information about all of the things we talked about today. And what you see is it's not just information from Google. There's great usability research linked from Yahoo, Facebook, Plaxo, et cetera. A lot of different people playing in this space. And like I say, we're looking for other people to play in this space to help us evolve. Well, thank you very much for y'all's time. And like I say, if people just want to go up to the mic and ask questions, I'll do my best to answer as much as I can now and stay after for people who want more detailed information.
A lot of us have legacy applications that have their own layering of authentication, authorization, and so on that we are trying to connect with cloud-deployed apps. And so we're looking both for authentication as well as authorization, not just authentication alone, with the minding that the ID is different, as well as the password may be different in different legacy systems.
Right. And so there are a couple of different pieces of that. One of the things he was asking is, hey, what if you have a legacy system that wasn't designed to deal with all this OAuth and REST API from the beginning? What if it was designed to deal with more of like a WS Trust or something else? Well, this is where, again, community stuff is really helpful. A lot of the companies have been more in the enterprise space, Microsoft, IBM, CA, et cetera, are coming and saying exactly this. Hey, there is this API endpoint in the enterprise. All it knows how to do is to get a blob in this HTTP header and then to either statically validate it in a certain way or send it over to this internal token server to verify it. So one of the things that we're working to try to standardize in OAuth is how can a calling application make a request to enterprise and go to like a central server in the enterprise and go to that central server in the enterprise and say, hey, I want to talk to your ERP application. Can you be a little bit more sophisticated? Can you talk OAuth so I can prove who I am and give me back a token that maybe will only last for 5 minutes that I can then send to a more legacy application that only deals with a token on a proprietary format. So how to use OAuth as a way to bootstrap grabbing one of these pieces of information. So that, that's part of it. Another part is, okay, a lot of those applications are looking for assertions in that blob as to, say, the membership of that group, like, is he in the auditors, team, for example. And again, these, central identity services, token servers, whatever you want to call it, they can use OAuth as a way to bootstrap, get information about, say, Tom in my example, or the application URL, and then swap it with, say, this proprietary blob that still has Tom's name, and maybe even internally a company looked up and said, is Tom an HR person? And then stick that in the blob that is sent along. And so Ping, IBM, CA, et cetera, they already provide these types of token servers that run in an enterprise and deal with things like WS Trust, WS Fed, SAML, et cetera. And OAuth is just another combination of the alphabet soup mix that they're looking to see, can they act as a bridge to these internal applications, just as in one of the early examples I showed how Ping Connect can be sort of a broker bridge to a lot of federated login vendors. These guys are trying to provide software to be that sort of last half-mile bridge. And hopefully that's helpful. We can talk more if you wanted. Yeah.
Okay. So there's been a lot of focus. I use Amazon AWS quite a bit, and now we're trying to link a couple of things between Amazon and Google App Engine. In terms of security, there's been a lot of focus to use GET as opposed to POST.
Right.
And a lot of times we have data that we're actually trying to send over. And I understand the purpose of using the signatures, but we're limiting the size of this URL, and we're limited by that. And ultimately, we have to do something about this. And if somebody wants to just mess with the system for the sake of messing with it, and they choose 200 lines worth of names for the username, this thing breaks.
Right.
So what's the solution to that?
So you might want to catch Brian in the OAuth help desk afterwards for more detail. There is a mix for body signing as opposed to just signing the head. We're not seeing it getting used as much as we would have anticipated. Like, we thought we were going to run into that URL problem like 6-9 months ago. We proposed some standards for how to deal with it. I'm not sure if they've been finalized. I think they're posted. Some people use them, but they haven't just been used enough for people to say absolutely works. We have data that it functionally works, enough individuals, but we'd like to see heavier usage of it to sort of formally ratify, yes, this is the correct way to do it. The other challenge that we have, again, for those who want to get more deeper in the crypto aspect, is creating these signatures is complicated. A lot of people find that signing something that's in a URL format has a lot of complexity to it. Signing just a blob that's in the body is in many cases actually easier. So not only does it avoid the length problems, but it in many cases is just easier. So I think search for OAuth body signing, Brian, is that? Yeah, so if you do a Google search for OAuth body signing, you'll see a spec for how people are doing some of that today.
Do you suggest using post?
So for those of you here, Brian was saying, if you've got a lot of data, you have to use post. You really don't have another option for you. Right. Cool. Great. Anyone else want to volunteer to stand up at the mic? If not, like I say, I'm going to hang around and answer questions individually.
I also have a question in regards to the container authenticating to multiple applications and potentially having a cookie for each application. Mm-hmm. How does the web browser secure or attempt to secure those cookies so they cannot be stolen by some other application running inside the web browser, so that they're in a secure container that can only be accessed by one of the member applications within that container?
Right. The dumb version is use one subdomain per app if you're able to do that, which say like Google App Engine can. If, however, your apps are running on a single domain like they do with gadgets, this becomes a much more complex story. In fact, so complex that's why OpenSocial had to be a standard. So it could be pushed out there and other people could look at the code and see that, oh yes, they did find a way to do that. It's very tricky. It took a while to get right, probably 9 months, and most of it was Brian Eden over there, by the way, so you could ask him for more details. But like I say, people weren't sure it was even going to be possible, so we had to make open source implementation of this so people could review it and say, oh yeah, actually those mechanisms do work. And usually it involves still running each gadget in its own subdomain, actually, with a unique to that subdomain token that identifies the user. To the user's web, to the end user, it looks like they're all running within one URL, one domain, but they're hidden iframes to independent subdomains. Great.
Yeah.
Sure.
And my next question was, I don't know if you've mentioned the Secure Mashups Hub framework and the availability of those secure channels between for instance, two widgets or two gadgets running within your browser where they can encrypt the communication, they can if you will, authenticate each other and exchange data within the browser itself. Yeah,
so what he was asking about is if you do have multiple gadgets, say, running on a page and they want to communicate with each other, they can communicate through the server-side channel. Tends to be slow, a lot of latency. There are a lot of tricks, and it varies by web browser, of how they can communicate within the page. However, the variance across the different web browsers is pretty high. So actually there is, I think it's called IFPC, is a open source set of code within OpenSocial that actually has 8 different ways of doing this, and auto detects what browser is used and what browser version is used, and then tries to use the fastest one. So some of that code is actually available, and you can grab if you want to use it.
Thank you.
Sure.
Yeah, hi. I have a question. I really like REST APIs, etc. Really awesome. But is there any thoughts within OAuth to support other RPC protocols like XML RPC or JSON RPC, which still run over HTTP?
Sure. So there actually are a lot of enterprises who use it for basically SOAP requests. What they end up doing, SOAP, short version is SOAP generally suggests putting the identity of the calling app and even the calling user within the payload of the application. And what we're seeing a lot of enterprise doing is saying, you know what, just take those 2 parameters and pass them in the URL, use OAuth to sign them, and have the SOAP endpoint get everything it needs other than those 2 parameters from the request. So we see that one. The other variant we see, slightly more complicated, is that if the enterprise does have one of these on-site sort of token server things that we mentioned before, your calling application can make a call to that one that's just OAuth and get back a blob, and then stick that blob in the SOAP parameter that it makes to a final legacy endpoint. So those are 2 different models that we're seeing now. It's not obvious if one's better than the other or if it really just depends on the use case.
Okay.
One issue that you didn't really deal with, and I don't know if this is the appropriate forum, but really handling the different secrets and keys and so forth.
Yes, crypto hygiene, as we call it. That's probably the #1 reason we'd like to change this from being a software-based solution to a service-based offering. Like I say, if the applications are running on 2 different containers and, Google on one side and Yahoo on the other side are doing all the crypto underneath, I'm going to trust them to get the crypto right, to rotate the secrets frequently, use RSA to bootstrap HMAC and all these, tricky things. So yes, right now it is very common for, sadly, enterprises to deploy this stuff, not have good crypto hygiene. For those of y'all who are too involved in this, the most common example is an administrator had access to one of these powerful secrets, and he leaves the company or is fired, and you don't change it, and he still has it, and he can make requests that impersonate one of your applications. So getting the crypto hygiene is good. While containers are trying to get in this, like I said, Ping Connect is offering some early versions of an OAuth platform to also deal with this stuff. However, the standards for that type of crypto hygiene, doing it automatically, are still only in just proposed stages. We haven't seen solid use of them yet to decide what's the best approach. Okay. Well, I think we're at a good stopping point. So I appreciate all of you all came by and didn't run off to get your new toys. Thanks.